Okay, so when we last left off, we were looking at step 3 of the sports league diagram that we've been working on based on the original soccer case with a couple of extensions where we're looking at the games. We're no longer storing specific points or the number of points in the game table. We're now storing each individual point in the game point table. And so we can get a reference from game to game point and get some aggregate functions on those game points to figure out how many points per game. In the meantime, we will actually have to put a couple of these things into practice to make some sense of them. So we're going to start building this database. Now, once you've designed a database, deciding where to start building is sometimes the most difficult part. And the tip I'll give you is to look for something that has no dependencies. And how do you know what has dependencies and what doesn't? Well, your dependencies or the tables that depend on other tables will always have a fork stuck in them. So our crow's foot will be stuck into a table if it has a dependency, which means we have to look for a table that doesn't have any of these crow's feet going inward. Outbound crow's feet are fine. So we can just pick a table at random. I'll start with game point just because it's the top leftmost, and I'll follow its crow's feet uh, backwards as best I can until I find a table that does not have any crow's feet coming into it, so no forks are stuck into it. So I can go this way maybe, and I find there's a couple of forks stuck in me here, so I'll follow those, and I go to the team and I find there's a fork stuck in me, I'll follow that. I end up at the sponsor table, which has no forks stuck in it. What that means is that the sponsor table doesn't depend on any other tables to exist. It has no dependencies. It has dependents, which is kind of just a way of confusing you a little bit because there's so many different words to describe what we're talking about. Um, but if we have a look around again, we may find other tables in our diagram that don't have any, like the guardian table and the coach table don't have any forks stuck in them. While we're here, let's throw in some guardian information because we kind of missed that. Guardian doesn't have really a primary key, so we'll put in guardian ID and a guardian first name and their last name. We're going to need to refer back to this later. And as a guardian, remember we originally talked about, oh, easy. Originally we talked about potentially the guardian or the people who are allowed to pick up the player is really what this guardian is all about. Might be a father, mother, stepfather, stepmother, brother, sister, uncle, aunt, babysitter, or caregiver of some kind. Whatever the case might be, there's a certain relationship to the player. So I'm also going to store this guardianship type in the player guardian table. Why not in the guardian table? Well, because that guardian may be a guardian of multiple children in there, and one could be their son, one could be their daughter, one could be their stepson, one could be their stepdaughter, one could be their friend's daughter, and they're just labeled as a caregiver and able to pick up that child. Whatever the case is, if we put it in the guardian table, then it wouldn't be able to change with its relationship or with the guardian's relationship to the player. If we put it in the player table, the same problem happens. So the guardian type will change depending on that key relationship between the guardian and the player. So that's why we put the guardian type in there. Okay, so let's try to take these models and now represent them in code. How do we do that? Well, we've been doing it right from the very beginning. It's just these crow's feet are kind of sometimes throwing us off a little bit because they're a little newer. But let's see what we can do. Let's start with the sponsor table. That was the first one we found, but coach and guardian would be okay as well. So sponsor. Let's go to SQL, and I'm going to just create a database for this example. I'm going to call it just soccer. New database soccer, S-O-C-C-E-R. Okay, and now it usually starts at the bottom there. I can refresh, and we get a new soccer database over here. And if I open it up, you can see I've got no tables. I'm not cheating. I'll refresh. There's no tables at all whatsoever. And I'm going to start a new query window. And in my query window, I'm going to write all the create table statements for those tables that we're working on. So starting with sponsor, then we'll create team, then we'll create well, we can pretty much go a lot of different directions from there. We can create team coach then we can create game, we can create game point once we have game created. We can create player once we have team created, and we can create game point once both game and player are created, because we've got two forks stuck in it now coming from those places. Then if we create this team coach off of team, we can't really do that until we have the coach table. So we got to make sure that we've got these all done in the right order, going from parent most to child most. So let's go back and we'll start from sponsor. Okay, so sponsor, create table sponsor. Oops, horrible misspelling there. And I know I have a sponsor ID, which is an integer, and we'll make pretty much anything with a star on it that doesn't have an external source, and we call it an ID field. So if we don't have like an external key, we're going to have the database automatically create it for us. So we're going to need a sponsor name and a sponsor city column. Sponsor name. Our sponsor ID was marked with an asterisk in our data model, so that's a hint to us that we're going to create a primary key out of that. So we need a constraint, pk sponsor ID, which is a primary key constraint, and that primary key is on our sponsor ID. Remember, the naming convention is just pk underscore to say we're naming it, or we're making a primary key constraint. That's what we're naming our constraint, and we're going to do it on this sponsor table. We use the table name because that way, if we have another sponsor ID column on a long shot in another table, we have a way of differentiating between this primary key and another primary key. And then we label out that this is the name of the column in this table. So it's a way of kind of making this constraint name unique, and also give us sort of a breadcrumb trail back to where the constraint is if we do happen to accidentally trigger an error at some point, perhaps by trying to insert something when we shouldn't, and so on. We also need, in this table we have no dependencies, so we don't need to worry about foreign keys. So there's no fork stuck in it, there's no foreign keys. Every time there's a fork, there's a new foreign key. So now from sponsor, we go to team. Let's create our team table. Now we have to create this foreign key constraint. And we know what the foreign key constraint points to and from, at least entity-wise, based on our data model alone. And that is that we have a fork coming into team, which means that sponsor is sticking something into team. And what it's sticking into team is a foreign key. So our team is our child table, and it has a foreign key, which you could possibly think of as a little piece of DNA that's coming from our sponsor table. And the DNA is the sponsor ID. So now our team has a sponsor, therefore it has a sponsor ID to refer back to all that sponsor information in the sponsor table. So we're getting the team's sponsor. So that's what we're going to do. We're going to put in foreign key, and then the first part of the name we're going to, again, say that this foreign key or this constraint belongs to this table, and the underscore is followed by where the original key is from, or the primary key that it's pointing to. But since we're creating a foreign key constraint, we have to write in our foreign key constraint syntax here. So the first thing about foreign key that the foreign key needs to know is what our foreign key column name is, and that is sponsor ID. Now we haven't created that column yet. Normally we would do this before we got to the constraint, but I didn't really want to throw us off. So references, and then after references you give it a table, and you tell it which field from that table that you want to get the foreign key from, or the primary key from, the referenced primary key. So we're going to reference the sponsor table, and the sponsor table will then have a sponsor ID as its primary key. And sponsor, I've made that mistake twice now. So you can see over here, I've got the sponsor ID. This is what I'm referring to here, and this here is telling me that I'm grabbing it from this other table. Now, I'm going to Shift Control R because my red underlines are not cooperating. Now you can see here that I do have a remaining red underline. That's its sponsor ID, because this sponsor ID is supposed to be a column in this team table, which we have not created yet. So our foreign key column will have a sponsor ID. And we have to make sure that if this is going to be a foreign key that references the sponsor ID in the other table, we have to make sure that we use the same data type. The identity thing is not part of the data type, so we don't carry that over. And then we're good to go. We've taken care of our primary key, which we've marked off in our model with a star, and we've taken care of our foreign key, which we've marked off with a fork. All done. So I'll put a semicolon because I'm finished telling the database engine to create my team table. And now, as you can see, we can continue on from there. There are things that the team shoots, if you will, crow's feet out or forks out at. So the table's kind of surrounding team where there are relationships, and on the team side it's just the one single line, and on the other entity side it's a fork. What we're looking at is the team is the parent table, and these other tables depend on it. Okay, so now what I'm looking at is my team table connects to my game table. So I'm going to create my game table now. Now the game table will have a game ID and a start date. So I'm assuming it's going to be a start date and time. I think that makes the most sense because we start at a particular time of day when it comes to a game. It's not just any time of a day. You know, if you watch professional sports, they start at 7 p.m. or 5 p.m. or whatever time of day, and it's scheduled well in advance. So we know we have a date and a time. So we'll set that for our game start field. Then you can see we've got two forks in here that we're going to create foreign keys with. So first of all, we have a team or a home team ID. Let's just call it home ID. And our away team, we have an away ID. So 1, 2, 3, 4 columns in total in this database, in that table. Game. So we have game ID, which we can assume is an int identity. And we have game start, which is a date time field. And remembering in SQL, or in MS SQL, we want to make sure we call it a date time to field because it's the more efficient, less memory hungry data type. And for the sake of argument, let's make this a not null, so it's a required field. We haven't really looked at not nulls in this example yet, and we should go back and do another pass and choose our required fields. But we also have to add in our two foreign key columns before we can create constraints on them. Or, like we did before, we have to write in constraints and then fill in our columns to match. But either way, we can't have one without the other. So, our two foreign key constraints were called home ID and away ID. So home ID, and it's an integer because it refers back to the team there, right here. And so we have away ID, which also refers back to a team. So the team ID. And again, for a game to exist, you have to have two teams. So we'll have not null here, and we'll have not null here. And we'll add in our constraint. Now here we have to just fudge our naming convention for foreign keys, where before we put this table and then the name of that table, well, the name of that table comes up twice, so we would end up, I'll show you what the problem would be, and we'll come back and we'll rename them afterwards. So normally we'd say this is a foreign key from game to team, and then we would describe the foreign key constraint a little closer here by saying home ID references team ID field. Then we have another constraint here, and this one is where the away ID references the team's team ID. So we've got two references to the team table for two different reasons that we have to enforce. But you can see here that we use the same foreign key name twice. Now, IntelliSense isn't complaining at me right now, but if I tried to run this, say, in fact, here's what we'll do. We'll create sponsor, we'll create team. These should work just fine. And I'm going to drop them in a second because all I wanted to do is show you by example. But if I try to create this game table alone, you can see it says cannot create, drop, enable, or disable more than one constraint column or trigger named FK game, team. So we've got two here that are by the same name. And that would apply if we, for example, use these game sponsor, team sponsor, and we have the team sponsor from the other table. So foreign keys are actually independent naming-wise from tables. If I try to do that, I get the same problem. There's already an object named FK team sponsor, so I can't do that. But I can start with FK game, and then in the underscore, what we might want to do is describe the meaning of this foreign key relationship, the meaning of this constraint. So we're connecting to the home team through the home team ID. Well, let's just call it home team. And we'll do the same for the away team, underscore away team. So this is the meaning of these. So this home ID will have an ID that exists in the team ID over here for a team, for my home team for this particular game. And the away ID will also point to the team ID in the team table. But it will only point to through our away ID column.